Hello everybody, welcome into another lesson. Today we are going to talk about the volume of prisms and cylinders. We will start out here with our first example, which is a rectangular prism. If it's a rectangular prism or a triangular prism, what have you, a pentagonal prism, that means you have a base at the top and the bottom of the prism that are both the same shape, whether it's a rectangle, a triangle, a pentagon, what have you. Both of the bases are in that 3D shape. They are the same shape. You just add height, of course, when you talk about a prism. So the volume of any prism is that capital B, which is the area of the base, times the height. In this case, we have a rectangular prism. So we know about the height, but what's the area of the base of a rectangle? Just the rectangle itself. Well, length times width, right? We want the volume, we just multiply by the height. So that's where the volume formula for a rectangular prism comes in. Length times width times height. So let's say this rectangular prism is a swimming pool. We have a length of 100 feet. We have a width of 30 feet. We have a height of 20 feet. So it would be 20 feet deep. What would be the volume? So the volume is going to equal your length, which is 100 feet, times your width, which is 30 feet, times your height, which is 20 feet. Which, when we multiply, we'll do the multiplication here. 100 times 30, that's 3,000. Times 20, that would be 60,000. Then you have feet times feet times feet. That's going to be feet to the third power. So the volume of this pool, this rectangular prism, is 60,000 cubic feet. That's quite a big pool. That'd be quite a big pool, 60,000 cubic feet. Alright, let's take this on a smaller level now. I'm just going to change some of the dimensions here. Let's think of another use of a rectangular prism. Well, let's say we have a facial tissue box, whether it's Kleenex, Puffs, or some generic brand. It's usually in a rectangular prism. Sometimes it's a cube. It depends if you get the smaller ones, but your long classic box you think of is a rectangular prism. So let's say the length is 12 inches, right? The width is going to be 6 inches. The height would also be about 6 inches. I think those are about the average dimensions of a facial tissue box. Since this is a rectangular prism, the volume is going to be equal to the length, which is 12 inches, times the height, 6 inches. The width 6 inches, times the height also of 6 inches. Now we just have 12 times 6 times 6. So 12 times 6 times 6, that's 432. 432, then you have inches times inches times inches. That'd be to the third power. So the volume of this box is 432 cubic inches. The volume of the rectangular prism, a lot of boxes are rectangular prisms, so it'd just be length times width times height to find the volume of the box. Alright. So I think rectangular prisms are pretty straightforward here. Now, why don't we get into another type of prism, which is a triangular prism? the classic ones you use to see light pass through to form a rainbow, a triangular prism. So let's make a triangular prism here. Probably not my best work, but yeah, I'm not the best at drawing, but more to the point, we have a triangular prism, okay? So, of course, when we have a prism, both bases are the same. It could be top to bottom or left and right, but you have two of the same type of base. So, of course, to find the area of the base for this prism, we know the area of a triangle is 1/2 the lowercase b, 1/2 the base times the height. Well, we have two heights here if we're going to have a volume. I would call this height here for the prism. Alright, I would call, of course, deal with your triangular base. Let's say the length of one base is, you have your base. Inside the triangle, the straight line, that would be height 1. That would be height 1. The height of your prism going across here, that'd be height 2. We'll call that height 2. I'll move that down here. That'd be height 2. So really, the volume is going to be half of the base times the first height times the second height. That would be the volume of a triangular prism. So let's do some examples here. Let's say, of course, you have, I don't know, 5 meters for the base of a triangle. You have 3 meters for the height of just the triangle itself, but then for the whole prism you have a height of 10 meters, right? If you want to find the volume of that triangular prism, you're going to take half of the base, which would be 5 meters, times the first height, which would be 3 meters, which would be the height of just the triangular base, times the height of the whole prism, which would be 10 meters. Well, now it's just a simple multiplication problem. We go from left to right. You're going to have 1/2 times 5 times 3 times 10. So let's see, 0.5 is 1/2. 0.5 times 5 times 3 times 10. You get 75 meters times meters times meters is cubic meters. So the volume of this triangular prism is 75 cubic meters. Now let's go ahead and do one more example with the triangular prism. So let's say your base is let's say 25 centimeters for the base of just the one triangle face. You have a height of, let's say 20 centimeters. The height of just the base of the triangle is 20 centimeters. Now if you want the height of the entire prism, let's make up a number and say it's 100 centimeters, right? So we're going to take the volume formula here, which is equal to 1/2 times just the base of one triangular face is 25 centimeters, times the height of just one triangular face is 20 centimeters, times the height of the whole prism connecting both faces is 100 centimeters. Now we can go ahead and we can do the multiplication. It's just a straightforward multiplication problem. You have 1/2, which is 0.5 times 25 times 20 times 100. You would get 25,000. Then you have centimeters times centimeters times centimeters. That's cubic centimeters. So the volume of this triangular prism is 25,000 cubic centimeters. So that's really all there is to prisms, is just find the area of the base, which in this case is 1/2 of the base times the height of just that one triangular face of the prism times the height of the whole prism. Thus I denoted H1 and H2. But next we're going to talk about cylinders, which you could argue are a type of prism, but they're classified differently because the bases of cylinders are circles. So we have, I'm going to draw a cylinder here to the best of my ability. Alright, so that's your cylinder. Of course, a classic example of a cylinder is a can. That's a great example of a cylinder is a can. Or an even bucket, where, you know, the top and the bottom both have the same diameter. So the volume formula still applies. It's the area of the base times the height. Well, what is the area of the base of a circle? Because the bases of a cylinder are a circle. Well, the area of a circle is equal to pi r squared. That's the area of the base. Then to get the volume, you're just going to take that times the height. So it's important to know where we're getting these formulas from. If it's a cylinder but it's got two faces, it's going to be the area of the base times the height, and the area of the base of a cylinder is pi r squared. Then to get the volume, you take that times the height. So the volume of a cylinder is pi r squared times h. So let's say in the base you have a radius of, let's say 10 millimeters. You have a radius of 10 millimeters, right? Now the height of this cylinder is going to be, let's say 50 millimeters. 50 millimeters for the height. If you want to find the volume of the cylinder, it's going to be pi times what's the radius, 10 millimeters squared. 10 millimeters, that's squared, times the height, which is 50 millimeters. Alright. Now, we want to, of course, according to the order of operations, you do your exponents first. So you would have pi times, okay, 10 squared is 100. Millimeter squared is, well, millimeter squared. Then times your 50 millimeters. Now this just becomes a straightforward multiplication problem. We got to figure out, it's going to be approximately equal to. So in the calculator, we're going to put in, let's see here, pi times 100 times 50. You get approximately 15,707.96. Then millimeters squared times millimeters, that's millimeters cubed, millimeters to the third. So the volume of this can is about 15,707.96 cubic millimeters. So that's how you get the volume of a cylinder. Let's do another cylinder. All right, let's say the radius is going to be let's say the radius is 3 yards. We haven't picked on yards in a while. The radius is 3 yards. The height is, we'll say the height's 10 yards. No, we did 10. Let's pick another number. Let's say it's 12 yards. Right? Okay, so to find the volume of this cylinder, you're going to take, of course, you're going to find the area of one of the circular bases, which would be pi times the radius squared, which would be 3 yards. That quantity squared, you're going to take that area and multiply it by the height of the cylinder, which would be 12 yards. Well, of course, again, with order of operations, it dictates that parentheses come first. So you'll have pi times what is 3 squared? That's 9. Yards squared, well, that's exactly what it is. Yards squared times 12 yards. All right, now, well, we just have a really simple multiplication problem. We got to take pi times 9 times 12. You're going to get 339.29. Now yards squared times yards, that's yards cubed. Times yards, that'd be yards to the third power. So the volume of this cylinder is 339.29 cubic yards. So really, whether you have a prism or a cylinder, prisms and cylinders are similar in the fact that they both have two faces that are the same bases. Hey, I just rhymed. A prism or a cylinder has two faces that are both the same bases. So we will get into shapes in the next lesson where you have a 3D object that only has one base, which those would be pyramids and cones, which that'll be the next lesson, will be the volume of pyramids and cones. But today's lesson, whether it's a cylinder or a prism, the volume is equal to the area of the base times the height. Now, it's important to know, based on what type of base the prism or cylinder is, you need to know the formula for the area of that base. So again, if it was a rectangular prism, the volume will be equal to, what's the area of the base of a rectangle? the length times the width, and then you would take that area, multiply it times the height. It'd be length times width times height. If it was a triangle, you're going to take, of course, the area of the base is equal to half the base times the height of that face only, times the height of just the face, not the whole prism, just the face. We call that height 1. All that times the height of the prism, which we'll call height 2. If it's a cylinder, which is basically a circular prism, the volume, the area of a circle, which would be the base of it, is pi r squared. You'll take that area times the height. You'll have pi r squared times h for a cylinder. So it's just important to know where these all come from. So as I said, next lesson is going to be about cones and pyramids, taking the volume of those. Hope everyone has a good night. Take care.